So I think if people have completed, we'll move to tracing part. Uh, so did people copy the tracing last in the last class? I think no. So the ones we will discuss. Okay. So here in the main method, method A is called. So you just look at this control. So you will move to the method A. So next inside that we have println statement written in try block. So after the println statement, we have the statement in which throw keyword is used. So whenever we use the throw keyword, an exception is generated. So once exception is generated, so the control should go to the catch block. But in this method A, there is no catch block. So there is a block called finally. So either the catch block or the finally block should exist for try statement. Okay. So if we have not written catch statement, that will work, but finally statement should be there. If we don't write the finally, we have to write catch. Either one of the things should be there, catch or finally. If both are present, that is also correct. Okay. Now for this method A, so after printing inside A, the message inside A, then exception is generated. So actually it has to go to the catch block, but here it is not there, catch block. Okay. So this finally will execute. Finally block of method A will execute. Okay. After the execution of finally block, so from which part of the program the control is transferred to the method A, to that part of the program the control should be returned. Okay. So that is, see, from try block we have come, that is from the main method. So for that part it has to return. For this try block inside the main method, we have the catch block. Okay. So now control will move to this catch block. So inside this the message is exception caught. Okay, this message is printed. If you look at the output here, so first message is inside A, which is present in method A. Next A is finally. That means finally block of method A. Apostrophe yes, A is finally. Okay, then after that catch block inside the main method exception part. So this is with respect to method A. Next with respect to method B. So similarly, when B method is called, you just look at the B method. What are the things present inside the B method? Inside B, that message is printed as usual. Similar to the method A, inside B is printed. Next, see there is no catch block for method B. Okay, but there is a finally block. So finally block will execute here. So one rule of finally block is it will always execute whether or not the exception is generated. If the exception is there, that exception is handled and then finally will execute. If the exception is not there, directly finally block will execute. So finally means the term itself tells finally it has to execute. Okay. If it executes, B is finally, that message is printed. Okay. See, there is a return statement inside the try block. So that has to return to the main method. If the return statement is there, it has to return to the main method. Before returning, it will print the message B is finally and then it will return. Okay. So if you look at the output inside B is finally. Okay. Now coming to the method C. Okay. So in the main method, C method is called. So if you come to the C method, see inside C, same message is printed. That is with respect to method C. But one difference between method B and method C is in method B return statement is there. In method C return statement is not there. So when it comes to methods, general rule is if the return statement is there, from that line the control will be transferred. If the return statement is not there, it will move to the end of the method and then it will be transferred. Actually, if you look at the method B, return statement is present inside the try block. So according to the rules of method, if the return statement is there, that keyword itself tells it has to return back. So in whichever line it is there, it has to return back. Okay, it has to stop that method. But here, because of finally, the return statement will return to the main method only after execution of finally. So this is very, very important. Because of finally block, the return statement will return the program control to the main method only after executing the finally block of B method. Whereas with respect to C method, there is no return statement. So it will come to the end of the method and then it will return to the main method. So here end of the method means finally block will execute. So inside C, that message is printed. C is finally, that message is also printed. Okay. Now you copy the tracing. If you have not copied, copy the tracing. So with respect to explanation, we will see. See, in the above example, A, that is method A, breaks out of the try by throwing an exception, because we have written throw keyword here. So if we have not, suppose if you have not written throw keyword means, uh, so there will be no exception and finally will be executed. So in this case also finally is executed, but after the generation of exception, finally will block will be executed. Okay. So A breaks out of the try by throwing an exception. The finally clause is executed on the way out. B's try statement exits. That means it will end via the return statement. See, return statement is there, so B's try block will end. But finally clause is executed. See, the finally clause is executed before B returns. So that is the meaning here. Okay. So whenever the return statement is there, the control has to return back to the main method. But here, control will return to the main method after executing the finally block in the B method. Okay. In C, the try statement executes normally without error. So the difference between method A and method B and C is, in method A, exception is generated. In B and C, exception is not generated. However, the finally block is still executed. So that is the general rule. If finally block is there, the finally block will be executed always. See this note. This is very very important. Sometimes in interview they may ask this question. That is the rule of finally. What is the important rule of finally block? If a finally block is associated with a try, the finally block will be executed upon conclusion of the try. This is very very important statement, because for a try statement, more than one catch statement can exist, and nested try statement can exist, and we can use throw keyword. We can use throws keyword. See, many possibilities are there. One try, one catch block, one try, multiple catch statements, nested try statements, try statement with throw keyword, method with throws keyword. These are the possibilities. And lastly is finally block. So in all these cases, if we use finally block, then in all the cases finally will be executed. Okay. So if a finally block is associated with a try, the finally block will be executed upon conclusion of the try. That is meaning of this is, if the error is and if the exception is there, exception is handled, then finally will be executed. The exception is not there, then also finally will be executed. So that is the meaning of finally block. Now copy the tracing. So actually font size is small, so some part of the tracing I will zoom it out. Else, okay, pop it. Okay, we will move to the next topic. What theory is there here? Okay. See, the topic name is Java's built-in exceptions. Just take this topic name. So whenever we deal with Java programming language, so two things will be there. One is inbuilt, that is in library, Java's class library, and one more thing is what we can write in our program. So own class names, own object names, own methods and all. Okay, user defined. So now Java inbuilt exceptions. Exception is nothing but it is an object. So nothing but we have to consider the class names. So exception is an object. So if we consider object, then with respect to object, we should consider the class names. So inside the standard package java.lang, Java defines several exception classes. So as I said, exception is an object, so we have to consider class names. The most general of these exceptions are subclasses of the standard type runtime exception. So I think we have come across this exception classes hierarchy in the previous classes. If you just look at this exception classes hierarchy, I think we will have taken. Throwable is the superclass. For this, two subclasses are there, error and exception. And for exception subclass, again two subclasses are there, arithmetic exception and runtime exception. So exception becomes the superclass here. Arithmetic exception and runtime exception becomes the subclasses. Now, in this paragraph, inside the standard package java.lang, Java defines several exception classes. The most general of these exceptions are subclasses of the standard type runtime exception. So, subclasses of runtime exception means if you look at this diagram, you have to extend this diagram so then we can understand. Okay. If we have not written extension of this diagram, that's okay, but we have to understand this concept. For runtime exception, again we have the subclasses. That means runtime exception becomes the superclass. Okay. These exceptions need not be included in any method's throws list. See, throws is a keyword. In front of throws keyword, we have to write the exception class name. Okay. So these exceptions need not be included in any method's throws list. That means after the throws keyword, we need not write these class names. In the language of Java, these are called unchecked exception because the compiler does not check to see if the method handles or throws these exceptions. So that means at the compile time, it will not check. Okay. At the runtime, directly will come to know there is an exception. So in two steps, that is at the compile time and at the runtime, we come to know the errors and exceptions. Okay. The unchecked exceptions defined in java.lang are listed in below table. Okay. So you just look at this class names and meaning of these exceptions. Java's unchecked runtime exception subclasses defined in java.lang package. Okay. Exception. Exception and their meaning. Say arithmetic exception. Okay, class name it is. Okay, so you have to follow the rules. That means convention to write the class names. So A is capital, letter A is capital. See, if you look at the next exception, array index out of bounds exception. See, you just look at observe the capital letters they have used. A, I, O, and again out of. So O is a capital letter, B and E. So if there are more than two words in a class name, so first letter of every word will be in capital letter. That is a convention. It is not a rule. It is a convention. And if it is inbuilt class, that is it is present in Java class library itself, we have to use as it is. We should not change. If we write the class names, then either we can use capital letters or small letters. But better to follow this rule. Okay. For arithmetic exception, the explanation is arithmetic error such as divide by zero error. So this is one of the example, but still there will be some other errors which are related to arithmetic equation expressions and all. Okay, this is one of the example. So that is commonly used. Okay. Array index out of bounds exception. It is array index is out of bounds. That means if suppose if the array size is 10 and if you are trying to store the values in 15th location, 20th location, then we'll get an error. Okay. So that means we cannot store the values out of the array size. Okay. Next, array store exception. Assignment to an array element of an incompatible type. That means if we have written the array declaration as integer type and if we are storing floating point value, then that is incompatible type. Okay, compatible means of the same type. Incompatible means of different type. Class cast exception. Invalid cast. Cast means again conversion from one type to another. So in the examples we will come to know these things. conversion of one type to another. Type casting we say in C, C++. That means from one data type we will convert to another data type. Enum constant not present exception. So here enum is a data type here, like structure. Enumeration is one of the data structure. Data type. Okay, derived data type, or sometimes we can call user defined data type when we use the keyword type def. Okay, like structure it is there. So some similarities is there between enum and structure, and some differences are also there. Okay, an attempt is made to use an undefined enumeration value. Next, illegal argument exception. So illegal argument used